Our next lesson in pre-algebra is called Base 10 and Exponential Form. But first, let's look at today's goals for this lesson. Our goals for this lesson are write numbers using expanded notation, write numbers using exponential form. Let's look at our vocabulary words. I'm going to read a definition and then say a word. I want you to repeat it after me. A number that is to be multiplied by itself as many times as the exponent indicates is a base. A small number written to the upper right of the number showing how many times the number is to be multiplied by itself is an exponent. A symbol including a base and its exponent is a power. Okay, there's a comic at the top of the page. Davy says, kickball has 4 bases, softball has 4 bases, baseball has 4 bases. I wonder. Gravy says, what are you doing, Davy? Davy says, we're learning about base 10 in math, but all I can think of are games with 4 bases. And Gravy says, oh brother. Okay. Well, the numbers that we use, the symbols that we use for our numbers, do you know who they were developed by? They were developed by the Hindus in India. These symbols are brought to Europe by the Arabs. Therefore, the numerals and number systems we use are called the Hindu-Arabic system. Sometimes the digits are referred to only as Arabic numerals, but the full term is Hindu-Arabic numerals. Arabic numerals are the familiar digits that you know of. Do you know what the digits are? I hope so. Our digits are 0, 1, 2, 3, 4, 5. You don't have to write this down. 7, 8, and 9. Unless you really can't remember it, then you can put it in your notes. But these are the digits. That question is probably on your quiz, and it's probably on your test. So if you want to put it in your notes, that's fine. But these are the digits. If you count those, there are 10 of them, because that's 9, and then 0 makes 10. So there's 10 digits. The idea for using groups of 10 for counting probably originated from using our fingers. The use of a symbol for 0 and the idea of place value are additional important advantages in our system. Why do you think the number 0 is important? Well, astronomers and other scientists often need to work with very large numbers that can be written easily. A place value system allows the recycling of symbols. After 9, we simply write the numeral to the left of 0, 10, then continue counting until we reach 9, then we use 2 to the left of 0, and we continue to go, and it allows us to just continue using those same digits without having to come up with 1,000 more numerals. So let's talk about exponents. If I showed you this, do you remember what this means? What does this mean? Well, that's how many times we multiply 3 times itself. 3 times 3 times 3 times 3 times 3. We multiply it times itself 5 times. So 5 is called a power or an exponent. Okay, so if we were going to write our place value chart, right, units, and then the next place is the tens place, and then the hundreds place, and then here's the thousandths place, 10,000th place, these are the 100,000th place, and here's the millions. Okay, those are the places. Well, using powers, I can write this like this. Just a minute. Let me draw these lines down. Okay. I told you your teacher can't draw. See, I told you I couldn't. Instead of, I can do 10 to the 0 power. Anything to the 0 power equals 1. Okay? I can do 10 to the 0 power. And then I can do 10 to the first power, 10 to the second power, 10 to the third power, the fourth power, the fifth power, and the sixth power. Mathematicians can use exponents in expanded notation to show how place values count powers of a base. It's easier for them to write 1 times 10 to the third than it is 1,000, which that one's not really that big a deal, but whenever I get these 10 and 11 digit numbers, it's easier to say 10 to whatever power. Alright, let's go ahead and look at our problems. Alright, we're going to start with number 3. Number 1 is matching those numbers, and I'm going to let you do that. Number 3, it gives me this number, 50, 415, and this is what it has. It has parentheses something times 10 to the 6th power plus something times 10 to the 5th power plus something times 10 to the 4th power plus something times 10 to the 3rd power plus something times 10, to the 2nd power plus something times 10 to the 1st power plus something times 10 to the 0 power. Okay? The easiest way to do this is right here. Count how many numbers are after it. There's 1, 2, 3, 4 numbers after it. So this is going to be times 10 to the 4th power because there's 4 numbers after it. Okay? So my 5 is going to go here because there's 4 numbers after it. So I'm going to put zeros in these first two. Okay? My next number is a 0. 0 has 1, 2, 3 numbers after it. Since it has 3 numbers after it, I use 10 to the 3rd. So my 0 goes here. 4 has how many numbers after it? 1, 2. So it's 10 to the 2nd power. So it's 4 goes here. How many numbers does 1 have after it? It has 1 number after it. So my 1 goes here. 5 doesn't have any numbers after it, so it goes with the 0. Okay? That's the easiest way to do that number. So 50,415 would be written in expanded notation as 5 times 10 to the 4th plus 0 times 10 cubed plus 4 times 10 squared plus 1 times 10 plus 5 times 10 to the 0. Okay? Alright, let's try another one. Now that we kind of get the hang of that, I don't want to have to write all that over. Okay, here we go. My number it gives me this number. Number 5 is 1,603,793. Okay? So I want you to stop the tape. I want you to see if you can figure out what this number is, and then I want you to compare it with mine. So stop the tape and do this problem. Alright, let's look at it. Here's 1. How many numbers are after the 1? 1, 2, 3, 4, 5, 6. So I find the one with the 6. This is where my 1 goes. Okay? And after that, I can just put the numbers in order. 1. Now, if there's a 0, make sure. Sometimes they'll skip it if it's a 0. Okay? So make sure the 0 is there. 1, 2, 3, 4. That's 4. So it's there. Okay? That's what you should have got. You have to be careful with the 0, because sometimes your problems, if it's a 0, it won't put it. And it'll just look like that. Okay? Did you do okay on that one? That's basically what all of these problems are like. Let's try another one. Okay. This one has and actually this one is going to start with 7. 10 to the 7th power. Okay, the number it gives me is 29,602,100. Okay, I want you to stop the tape and put that in expanded notation. Alright, let's see how we did. Let's look at the first number, the 2. How many numbers are after the 2? 1, 2, 3, 4, 5, 6, 7. So it goes with the 7. Okay? My next number is 9, 6. I'm at 0, so I need to check it. 1, 2, 3, 4. It's there. Okay, so 0, 2, 1, 0, 0. Okay? Are you kind of getting the hang of that? Alright, let's look at number 9. Number 9 says to match the following terms. I'm not going to do all this with you, but I'm going to do the first one. I have 5 times 5 times 5 times 5 times 5 times 5. Now, how would I write that as an exponent? Stop the tape and write that as an exponent. Alright. Here we go. Well, first of all, I know it's 5, obviously. What power is it going to be? Well, let's count them. 1, 2, 3, 4, 5, 6. So my exponent is a 6 because there are 6 of them. You kind of get the hang of that? Maybe I should do one more of those with you just in case. 1, 5 times 5 times 5 times 5. Okay, now stop the tape and write that as an exponent. Okay, how did you do? Was that one easier? We know it's a 5. How many are there? 1, 2, 3, 4. So it's 5 to the 4th power. Okay, so whatever number's there is our base. That's what we write first. And then we count them, and that is our exponent. Okay? Alright, I want you to go ahead and stop the tape, review this lesson, and go ahead and finish the problems.